Hi, and this is Dr. Goff Louis. In today's video, I'll be talking about the Toshiba Thermoflagger thanks to the element14 RoadTest program. The Toshiba Thermoflagger is a small integrated circuit comprising a fixed current source, voltage reference, comparator, and output driver stage with logic. It is intended for use in interfacing PTC thermistors to digital inputs to form an over-temperature monitoring solution. Compared to circuits comprising of discrete components, the Thermoflagger requires fewer parts, uses less board area, is tolerant to varying input voltage, and may even consume less power. The Thermoflagger comes in 8 different types, which are combinations of PTC current, 1 or 10 microamps, latching or non-latching flag signal, and push-pull or open drain output. As part of this road test, I've been supplied the reference design for the TCTH021AE. This is a USB-C powered, credit card size demonstration board with 2 PTCs connected in series, a push-pull, non-latching Thermoflagger with 10 microamps of PTC current, and 2 MOSFETs controlling 2 LEDs with their own series resistor acting as indicators. A separate area on the board has another Thermoflagger with breakout connections for direct evaluation of the IC. It's hard to get a sense of scale for the SOT553 package. Here's what it looks like next to an SOT23. It's pretty small, measuring 1.6mm by 1.6mm by 0.55mm and weighing in at just under 3 milligrams. The functionality of the Thermoflagger can easily be verified by waving a heat source such as this hot air pencil over the PTCs, one of which alerts at 80 degrees Celsius and the other at 105 degrees Celsius. The resistance of the PTC increases dramatically with increasing temperature, causing the Thermoflagger to change state. Note that this series-connected PTC arrangement allows monitoring of multiple locations at the same time, however cannot distinguish which location is causing the overheating. It may also be vulnerable to overheating in multiple locations. As a result, careful selection of PTC is required to adjust the alerting temperature. The board can also be modified to accept other resistive input sources, including a force-sensitive resistor or a light-dependent resistor. Here I've disconnected the PTCs and attached an FSR, transforming the Thermoflagger into a touch or pressure-sensitive input. So testing on the bench now with the Keithley 2450 source meter unit and Keithley Kickstart software, and doing a IV sweep between 1.7 volts and 5.5 volts operating, we can see that with the PTCO disconnected, the self-consumption ranges from about 1.4 to 1.6 microamps. With the PTCO shorted to ground, because this is a 10 microamp Thermoflagger, the consumption of the chip ranges between around 11 to 12 microamps. The current output for the thermistor should be regulated at 10 microamps, and with it sweeping, it seems that regulation is quite tight as long as the PTCO is around 600 millivolts below the VCC. The output current is seen to be around 10 to 10.2 microamps, indicating excellent regulation. Testing with the Rohde & Schwarz MX04 oscilloscope and onboard function generator, I can see that there is roughly a 20 microsecond propagation delay on alerting. The minimum width for input pulses appears to be about 20 microseconds, and in terms of pulse release, after 100 microsecond pulse, the release time is around 227 microseconds. Testing of the voltage threshold with a ramp waveform seems to show that it is very accurately set at 500 millivolts, and by testing with a sawtooth waveform elevated such that it only just barely touches 500 millivolts at its lowest, we can see that there are no false activations, thus indicating the Thermoflagger is extremely accurate. In all, the Toshiba Thermoflagger is an IC that makes realizing PTC-based over-temperature monitoring easy by requiring less board area, tolerating varying input voltages, and requiring no redesign in case of changes in thermistor or input voltage. In return, due to its fixed comparator reference, it requires careful selection of thermistors to achieve the required alerting temperature. As a component, it really only has one job, and most importantly, it does it well. This has been Dr. Goff Louie, with thanks to element14 and Toshiba for this RoadTest opportunity. Please visit the element14 communities to read the full RoadTest review, and as always, you can visit me at gofflouie.com to see what I've been up to.